You walk into the exam hall, flip open your Cambridge IGCSE Physics 0625 paper, and you see a practical timing question. You write down what seems like a perfectly logical, straightforward answer, and you walk out feeling absolutely confident. But then, results day arrives, and you realize you dropped crucial marks. What happened? Well, today, we're skipping all the traditional revision fluff. In this explainer, we're going to decode the secret language of the Cambridge examiner and rescue those lost marks before you even sit for the paper. Take a look at this classic trap. Time the swing with a stopwatch. I guarantee you thousands of students write a variation of this exact sentence every single year when they're asked how to find the period of a simple pendulum. And honestly, it sounds completely right, doesn't it? You've got an action and you've got a measuring instrument. Yet, a Cambridge examiner is going to look at this and ruthlessly award it 0 marks. No way, right? So why? What invisible rule did this student actually break?
Welcome to Section 1, the Rubric Decoder Unlocking Physics 0625.
See, our mission here is to transition you from making these invisible revision mistakes to consistently locking down those top-end marks. Because here's the harsh truth. Just memorizing the physics concept, it's not enough. You can know exactly how a pendulum works, but if you trigger any of these really common traps, like missing units, rounding your data way too early, offering vague explanations, or giving weak practical improvements, your score literally plummets. Examiners are heavily trained to penalize these specific oversights. They aren't just checking if you understand the physics, they're looking for incredibly precise scientific execution.
Let's move to Section 2, the accuracy quick win, instant mark savers.
Okay, before we actually fix that disastrous pendulum answer, let's secure you some incredibly easy marks. When you're dealing with ticker tape timers to record really short time intervals in motion experiments, measuring just a single tick, it's a massive trap. The absolute ultimate quick win for improving your accuracy is the number 10. Measure 10 ticks instead of a single tick. Doing this massively reduces your percentage error, and it instantly proves to the examiner that you actually understand the mechanics of practical, experimental physics.
And this brings us right to a fundamental rule from our source material: accuracy can be improved by measuring longer time intervals. Now, in just a moment, I'm going to show you the exact examiner wording that guarantees you full marks for pendulum timing, but first, you need the framework that makes that examiner clue completely obvious. Seriously, if you leave now, you are going to miss the key phrase that transforms a 0-mark answer into a perfect one.
Section 3, the 4-step answer framework, the Cambridge Answer Engine. Think of this as an authoritative 4-step machine that you absolutely need to formulate a high-scoring exam response. When you use this, you literally leave no room for the examiner to dock your points. Here's the logical progression. Step 1, state the concept clearly. Step 2, provide your evidence or data, meaning exactly what you're measuring and with what. Step 3, apply scientific reasoning to explain how you're measuring it accurately. And Step 4, wrap the whole thing in examiner wording. You know, the specific terminology they are actively scanning the page for. Structuring your answer this way visually proves your total mastery to the examiner.
Let's try it out in Section 4, Spot the Fatal Error, Interactive Challenge.
All right, it's time to actively apply this 4-step framework. Let's look back at our original 0-mark answer. Release the bob and time the swing. I want you to pause for a second and predict exactly why this vague instruction completely fails the evidence/data and examiner wording steps of our framework. What data is actually missing here? What wording is wrong?
Okay, here's the critical error. When a student says time the swing, they so often just measure half a swing, say from point A to point B. They completely fail to realize what constitutes a true, complete oscillation in the eyes of a physicist. The bob must travel from its starting peak through the center to the opposite peak, back through the center again, and return to its exact starting point, A to O to B to O to A.
Let's fix this in Section 5, the examiner's correction, rebuilding for top marks.
It's time to rescue that 0-mark answer by rebuilding it using the exact, precise language that Cambridge rubric demands. Contrast the flawed answer with this perfectly constructed response. Time several complete oscillations using a stopwatch, then divide by the number of oscillations to find average period t. I mean, just look at how it hits every single requirement. It specifies the tool, a stopwatch. It specifies the exact evidence, several complete oscillations, not just one vague swing. And it provides the scientific reasoning for accuracy, finding the average period by dividing the total time by the number of oscillations. That right there is exactly how you lock down maximum marks. And once you've successfully calculated that average period, which we denote as a capital T, you essentially unlock the next layer of the exam. Notice this incredibly crucial, highly testable formula. Frequency equals 1 divided by the period T. Frequency is just the number of complete oscillations per second, and calculating this from your carefully measured period is pretty much guaranteed to show up on your papers.
Now this brings up a fascinating high-level question. Why are examiners so incredibly obsessed with precision when it comes to measuring time? Well, it's because in physics, time isn't just a casual measurement of days or hours. A second is fundamentally defined as the time interval for a certain number of energy changes to occur in the cesium atom. Think about that for a second. When you realize that the foundation of time measurement actually relies on subatomic energy changes, it makes perfect sense why an examiner won't just accept time the swing. Precision is literally the soul of physics.
So, before you move on to the next question in your exam, you absolutely must run this final safety check on your perfect answer. Are your units present and correct? Like seconds for period and hertz for frequency? Are your significant figures appropriate for the instruments you used? And finally, is your data actually reasonable? I mean, if you calculate the period of a 30-centimeter pendulum string and get 45 seconds, your data is definitely not reasonable, and you seriously need to check your math.
All right, we've completely decoded the simple pendulum and the ticker tape timer. We have the accuracy framework locked down tightly. But what happens when the motion isn't a simple repeating pendulum? What happens when you're dealing with an object in free fall, accelerating downward until it hits terminal velocity?
That is exactly where our framework needs to be applied next. Analyzing terminal velocity graphs introduces an entirely new layer of complex examiner wording. We've mastered the simple pendulum, but ask yourself, if an object's acceleration is constantly changing as it falls through the air, how does our four-step answer engine adapt to capture those missing marks? That's the real test of a top-tier physics student. To uncover the next code layer and master terminal velocity, you need to jump into the next explainer right now. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. See you there.